Okay, this is the next example about the open loop control system. We are not going to have example on closed loop, so for that we have two example here on the open loop, but we have similar formulas will be applied for a closed loop control system for control for positioning system of the NC machines. So in this example, actually, he said the work table of the positioning system is driven by a lead screw whose pitch equal to 6 millimeter. The lead screw is connected to the output shaft of stepper motor through a gearbox, and he gave you the gearbox ratio here, which is RG. Okay, so then the stepper motor has 48 steps. I talk about the steps here, or NS. Then the table must move for a distance of 250, which is the value of x that we use in our equation before, I mean formulas, at a linear velocity, which is vt here. The linear velocity that we talk, it's the movement, or the velocity of the movement of the table. Then as you can see here from the gear ratio here, this is the 5 is for the motor, related to the motor side or the motor speed, and here for the lead screw. How many pulses required to move the table the specified distance? That means specified distance, which is the 250 millimeter. How many pulses is required to be input for the stepper motor in order to move the table up to 250 millimeter? Okay, the second is, what's the required motor speed and pulse rate to achieve the desired table velocity? We have a desired velocity for the table here we want to achieve. So what is the required motor speed, which is the n for the motor, nm, and also the pulse rate for the motor. Okay, so as you can see here from the previous formula, we have a equal to 360x over p, which is p here the pitch, and the x is the distance or the displacement of the table here. And if we want to find the angle of the lead screw here rotational, which is a, we can use this formula. So we just apply substitute for the value of x, which is 250, and the value of p, or as is in the example here, the pitch which is p is equal to 6 millimeter. Then this is the angle, which is 15,000 degree angle of the lead screw rotation. Then we have a formula said alpha, which is the angle of the step angle, is equal to 360 over ns, or number of pulses here. According to the this he said the motor has 84 steps angles, 84 steps angles, which is the ns. Then we have 3060, because the complete revolution is 360, so we can find the value of alpha, which is 7.5 degree. After that, we have a formula said mb equal to 360x rg. Please correct this one in your slide, because it was like multiply, it's not multiply, it's x. Okay, so 360 x rg over p alpha. So we have 360 times x, which is already mentioned 250, rg, which is the ratio of the gear ratio, okay, over p here is the pitch, and alpha is the angle of or the step angle. Okay, so all these parameters, 360x over b, can be replaced by using a, or this here, according to this formula, 360x over b is just substituted here by the value of a that we already calculated, which is 15,000. Then rg, we have 5, according to the question here, the rg 5 over 1. Okay, so it is 5, and we have the alpha that we calculate here, 750, just we place it here. So the number of pulses here that required, which is in part a, how many pulses required to move the table specified distance of 250 millimeter, is equal to 10,000 pulses. Okay, so this is about the first part of our example. The second part here will be more on the required motor speed, which is nm, to be and the pulse rate also for the desired table velocity, which is the value of vt. We have a formula set, you can just include in your slide. Actually this formula is from here. Vt is equal to frmp. So this is mb. Actually in the original one it was p small here subscript, but it's not correct. It should be vt is equal to vr equal to mb, where p here leads screw pitch, and fr is table feed rate, and vt is linear velocity here, in millimeter per minute or in inch per minute. Please add this, correct this information. The p here it was like subscript, it's not subscript, it's like original parameter in the equation. So this is the formula: vt equal to vr equal to np. So what is vt here? Vt is and based on according to this formula here, n equal to vt over p. Okay, so we have p equal to 6, it's given the pitch is 6, and also the vt here is 500. According to the example here, he said the speed is, the required speed is, the linear velocity is 500. So we just substitute for the value of the linear speed, which is vt, and the value of the the lead screw pitch, which is 6. So just give, this is 83.33 revolution per minutes. Revolution per minutes. Okay, A3. This is the speed of the motor. Then we have a formula said ratio or gear ratio here is equal to nm over n. We just, since we already have the the machine n here, as you can see, rg here is, we can find it, the formula is in this slide here. rg equal to am over a, or equal to nm over n, where nm is the rotational speed of the motor, n is the rotational speed of the lead screw. We already find the value of n, but we need to find the value of n. So this value is there, this value is 5 given in the example, and we can find the value of the rotational speed of the motor. So we just substitute the value v nm over n equal to rg. So nm equal to 5, which is the ratio here, come from 5 over 1, so it is 5 times the speed n, which is 83.331. Okay, so this will give you the speed of the motor, or the required speed. Because the question here, he asked about two things: motor speed, which is nm, then pulse rate, which is the value of fp. Okay, after you find the value of nm, we have a formula said fp equal to vt ns rg over 60b. Okay, so you can refer to the original formula here: fp equal to vt ns rg over 60b, or equal to fr ns rg over 60b, the same. But since we have the vt value here, so we substitute for the vt value that we already have is 500, and the ns value, which you already have, as 48, according to the number of step, or the step angle here. And then we have the rg, which is the ratio, or the gear ratio, and we have 60b, which is the pitch of the lead screw. So we just substitute to find that is the frequency, which is 333.333 hertz. Okay, so this will be the frequency, the pulse rate, to achieve the desired table velocity, which is the 500 revolution millimeter per minute. Okay, please go through the examples again, all examples in this chapter, and you need to memorize and understand the formula and how to use this formula to calculate the different parameters for either in this section or also in the previous and coming section.